Presentation and started. Now, I do hope you see that little comic thing about on the first page. Is everything viewable properly? Right, great. Let me just start by saying that I was wondering about my contribution to the institutional support group. I was trying to figure out what institutional support means, and my original hunch was that what Nicole is doing is much closer to things being provided to institutional people on a horizontal basis. But what I will be describing here is a concrete, quite narrow effort to try to help my university scale up its laboratory-based education, which is a crucial issue if, let's say, my university or other distance learning universities try to, how would I put it, trespass what conventional universities are doing in engineering or other studies that demand laboratory training. Let me just move on a bit. So, well, I'll skip that slide. We don't need that. So what happens when somebody is being practicing, let's say, physical sciences on an on-site laboratory? What happens is that you have some, say, a limited amount of space, and then you have to have quite a few people, quite a lot of students into a laboratory, and you also have to work to very tight schedules about who comes next to use what kind of equipment. And then again, students don't have access to the equipment all the time, and you also always have and run the risk of accidents. For example, if you do biology or chemical labs, there is always the risk of hurting yourself or hurting other people or damaging stuff. So why this is a particular problem for us, and that's where institutional support comes also, is that we have huge dropouts. Now, huge is not something that is unlike what other distance teaching universities are reporting for similar classes, science or engineering-based classes. But basically what we do is that when we teach our students natural sciences, we ask them to do, let's say, a full-year, full-time studentship, and we view them, we see them, let's say, 4 or 5 times a year for a consulting session, and then we ask them to come to where the university's premises to do some short focused laboratory training after they have read a lot of books and watched a lot of videos throughout the year. Now the question is, when they actually come on our site, we usually waste the first 30 or 40% of the time that these students would be spending on doing exercises for familiarizing them with equipment. Because regardless of whether they've written a lot of books and watched a lot of videos, when you are being presented with actual microscope, you feel like numb. You don't start using it. You're just wondering whether you're going to mess it all, and then time slips away and exercises don't get completed on time, and then we get very concerned about whether what we've given our students is what we had promised them. So we have, what we have been working for the last, let's say, 4 or 5 years is 3D simulations, which will allow students to take home software that will allow them to practice as much as they want, and that's where the unlimited trial and error testing goes, for preparing themselves for when they actually come to our university, so that they have as much practice as they need. And here's a view from the software that gives you a view of the realism that we are expecting the students to familiarize themselves with. What you actually see here is a full digital microscope, and then a lot of scales and a lot of stirrers and a lot of biology-related equipment, which students can actually pick, press, put on the table, take home in an inventory, combine in order to make dilutions. So what I'm now going to do is give you a very, let me see how I can share my desktop for a while. I found a way to do it. No. No, I can't actually do it. I was trying to share my desktop, and it looks as if I have to download first something. So then I will pause it again and come back to the presentation. And let me get back to the slide where I was. But instead of actually sharing my desktop, I will copy the link of the demo in the chat so that you can see the online video for yourself. Is that clickable from your from our PCs? So what I'm showing you here is the level of realism we expect our students to practice with when they have the software at home. So they can do a lot of experiments with, it covers, let's say, something like 15% of their full assignment. But what we hope to get them practicing is for them to familiarize with actually using that equipment. So when they come to the laboratory and they use the real thing, they have as few as possible concerns about their safety and about whether they are familiar with how to do things. For example, if you handle a microscope like that, your first insight might be like, if I pop my eyes into these lenses, then I will be able to see something. But in reality, what actually happens is that you need to use a lot of knobs and a lot of buttons and a lot of levers in order for you to actually see something. So we hope that by asking them to simulate the whole process in a non-quantitative way, but simulate it in terms of steps being taken, that when they come to our premises, they will be able to do the same thing with less apprehension. So what the video is going to show you, and if you feel you can find the time, you can actually download the whole thing and try it for your full learning, with a full learning activity, is some simple chemistry and biology related things, which is a use of the optical microscope and how you actually prepare a dilution. And now we are working on very complex processes, such like electrophoresis, which involves, let's say, something like 20 or 30 pieces of equipment, and there are concerns for people's safety as well when you're actually carrying out this kind of experiment, which can take anything from 1 hour upwards in the real lab. So we hope that if we have the software sent to the students, when they come here, they will be able to get on with it much faster and much more effectively. Now, why I am talking about institutional support with this kind of presentation is that this is a very expensive undertaking. And if one looks into the future and says, okay, I'm going to be covering biology, chemistry, sciences, or some engineering courses, then you actually need to invest a lot of effort to develop experiments for as many of them as possible. Not all of them at the highest possible level, but at least, let's say, the 50 or 60 introductory percent of simulations. Because in reality, when you are in the lab and you've spent 2 or 3 days, then things get going. It's the first 2 or 3 days when time passes without you actually doing anything because you are worried about if you are doing the right thing or not. And that's where the line is drawn about to what needs to be done at a larger scale. And that's where our research comes into, which is we want to start looking into what happens with assessment and examination. And first of all, assessment. If I prepare a dilution and I take an awful lot of time, I should be given some feedback on that. And if, for example, I may not spend a lot of time, but still I do a lot of useless steps, then somebody should be alerting me on that. And when I say something, I'm not saying about a live teacher. I am saying a live or a tele-live teacher. I'm talking about the software detecting my moves and raising a yellow card alert of whether I'm on the right track or not. And that's where scaling up comes into. Editing wizard means that we are developing a gallery of equipment and processes so that tutors should be able to compile their own experiments for issuing them back to the students. So we start with hardwired experiments, but we want to scale up to experiments that are modifiable and edited by tutors. So why are we doing that? Because we need to improve access to laboratory education by reducing its cost. And now that's a policy level decision for my university. It definitely is for the country because means are far fewer than they used to be. So we have to make do with less and still have our students give them, a reasonable level of education. And that's our challenge. Elevate at a distance lab education to at least the same level of learning effectiveness compared to on-site lab education. Because if you manage to do, let's say, a lot of things by simulation, then you can start talking about developing new modules without actually having to procure the equipment for the experiments. Now, of course, you can't do that for medical education. So we have not ventured into medical education yet. But where biology and chemistry and physics and some mechanical engineering and some civil engineering is concerned, people here seem to like this kind of approach for downsizing the cost. So here's the thing that you can come back and download the whole thing and play it for yourself. So I'm coming back to why I consider that institutional support. It's because, and this has to do with one of my questions to Nicole about how do you deal with subject experts. This work started because I was next door with a biology teacher who was striving to get her students, moving on with equipment. So I think that you need to work with subject experts very closely so that when they use ICT, they get to see a whole new opportunity of doing things. You just don't give them ICT for changing themselves a little bit. You need to give them a perspective of changing at a big scale so that they can see the motive for investing into that. A little delta will not do them a little favor. But if they can see a big picture where they can do what they want for larger scales, then you have the real. So that was more or less about it.